Hello, everybody, and welcome back to Coffee Break, the show where we break down interesting topics all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and today I am joined via the power of the internet, all the way from Trondheim, Norway, Johan Lafstad. How you doing, Johan?
Hey Clifford, I'm fine, thank you.
I'm very glad to have you here. Johan's going to talk to us all about setting up an AWS IoT cloud application, but before we go through that journey together, I'm going to throw it over to Michael Pierce in the booth, and he's going to tell all of you wonderful people how to participate. How you doing, Michael?
Good, thank you, Clifford. And definitely looking forward to today's discussion on AWS. I've had a few goes at it myself. Okay, so welcome everyone. We're on Facebook, YouTube, and LinkedIn live right now. Please share us, and also please submit your questions in the chat, and we will attempt to answer them after the discussion. Also, there may be some people online that can answer some of your questions in the chat as well. If you like us, share us. If you need to if we don't get to your question, please email us at livestream@microchip.com.
Absolutely.
Back to you.
Thank you very much, and we will make sure Johan answers your guys' questions if they come in. So, Johan, first off, for the people that may not be familiar, I want you to start by breaking down what AWS means in relation to IoT.
Sure. So let's start with what actually AWS is, like in general. So it stands for Amazon Web Services, and it's the cloud computing service that Amazon delivers. It's basically a platform where you'd host any kind of online service. So for instance, a lot of the web is hosted there, a lot of websites. In terms of IoT, it's significant because it has support for adding a lot of IoT devices to their system. And you can use the system to send commands and actuator commands to the different devices you have out there. You can collect data from them. You can store this data and do further analytics on this data as you go forth.
Cool. So other popular cloud providers like Google Cloud and Microsoft Azure, the concepts that we're talking about will still apply to those cloud providers, but for today we're just going to be deep diving into AWS, right?
Oh yeah, definitely. Like, for instance, with the Google Cloud Platform and Azure, they both have IoT support. They have it's a little bit different than how you actually communicate with these clouds and best practices in terms of security, for instance. But in the broader strokes of things, they're basically the same.
Cool. Well, I wanted to ask you, in your perspective, what are the main challenges that somebody would face when they're beginning an IoT design or application?
Sure. So when I look at IT projects, I like to say that there are three factors that are more important when dealing with IT project than maybe with more traditional embedded projects. So let's start with the first one, which is complexity. In general, when dealing with IoT devices, the software you're working on is more complex. You often need larger, what we call software stacks. So let's say you're going to use AWS. You need then to use most likely MQTT, which is a protocol to communicate. It's a not peer-to-peer, sorry, a pub/sub communication protocol that you'd need to communicate with AWS IT Core. Again, to use that, you need a TCP/IP stack, and on top of that, you need a driver for an actual Wi-Fi module, and so on and so forth. And it really just adds up to how much complexity you have to deal with.
Right.
So that's the first one. The second one is one that people often they kind of overlook it sometimes, but it's really important in a security. So in the security world, we have a term that we call an attack surface. And an attack surface is basically, like, imagine you have a surface. What attack vectors do you have towards that device? So in other words, how can you attack the device? If the device is not connected to the internet, it's not that big of a problem because you need physical access to the device in order to do anything with it. But as soon as it's connected to any sort of cloud solution, then you'll have to protect yourself from any kind of attack that comes wirelessly through internet. And that can be that can be a challenge.
That can be a huge problem. And like you said, security is something that's often overlooked, but once we need it, it is something that is super vital to the health and the viability of a product. And like you're mentioning, the surface area increases the more and more nodes that we add into a network, and our validity is only really as high as the strength of our weakest node, right?
Yeah, that's a very good point. And also, when just one of those is compromised, that can be an entrance into your whole system just through one compromised IT node. So it's actually really important to do security correctly when dealing with IoT.
And so from my perspective, it looks like the first and second, and probably the third as well, but the first two, complexity and security, kind of go hand in hand. The more security we want, the more and more complex the design is going to be. Is that how you view it?
Yeah, I'd say that's a fair assessment. It's like often you have deadlines, like, oh, you have to get this done by then the product is launched. And security is maybe one of the things they can easily cut down on because it requires a lot of investment, a lot of knowledge, and you don't really see it in the final product before it's too late.
Right.
Or let me put it another way. You notice the absence of it, but not necessarily the presence of it.
But it's incredibly vital to the whole thing.
Oh, really important.
And so the third point, sorry, I didn't mean to go on a tangent there.
Yeah, the third point I'd say is the assumed knowledge you need. So I think every engineer can relate to the problem of reading some sort of technical document or some sort of documentation, and they expect you to know something or have a background in something that you don't have. So, for instance, if you're reading a data sheet, let's say for an AVR, then you're kind of expected to know a lot of electronics and maybe a lot of low-level computation. But when you're dealing with, for instance, AWS, they expect that you, for instance, know how to use the command line with any issues.
Right.
So you kind of have to walk the line between an electrical engineer and a
software developer.
A software engineer. Yes, thank you.
So those are the three main challenges that you've listed. Of course, in any road to development, there's going to be lots of others. Do you mind walking through with us a sort of example journey of what somebody would go through if they wanted to design an IoT application and how Microchip can help?
Let's, like the title of the live stream is to create a sensor node. So let's do that. So the first step is, okay, let's plan what we're going to make. So, okay, we need a humidity sensor. I have here a clipboard. It's like temp, humidity, click 3. And a clipboard is just something you can, as a modular device that you can put into a, for instance, a IoT board. And this is the AVR-IoT board. It comes with a AVR microcontroller, a Wi-Fi board, and a secure element. And if we just connect it as so, we have a board
IoT
we can
connected.
use humidity.
Right.
Yeah. So that's the first step. The next step, I guess, is to actually explore the documentation. So let's make this okay, let's say we want to send humidity data to the cloud. I have a.
And so all of the links to everything we have talked about and will talk about are going to be available in the description and in the comments if we can. So make sure to look out for those guys. Sorry, Johan.
Yes. Yeah, thank you. So I'd say a great resource for at least for our IT lineup is the Microchip IT Developer Guides for AWS, which is this site. It's basically a tailored experience to get you started with IoT, and as it says here, it's a survival guide for your embedded to cloud journey. So It's kind of focused on our traditional customers, which are embedded customers, and it's a lot of different tutorials.
So you really have a roadmap right there.
Yeah, this is the path we wanted to take, and you don't have to go all the way. You can stop here, but if you want to learn more about cryptography, go straight ahead.
Nice.
We have lots of resources for that. So let's do the first one here, which is what we call connect the board to your AWS account. So let's say you have this board, you have plugged in the humidity sensor, but you actually want to connect the IT board to a AWS account you have set up to actually start receiving the data. That's what this tutorial explains. And You can, on your own time, read through this if you want to do yourself. We're going to skip over a bit of things just for the sake of time, but you need to download this IoT provisioning tool,
Right.
which is a tool that we use to connect any of our boards to AWS. I have already downloaded it.
Of course you have.
There is, yeah, I'm prepared. There is a few, let me also just bring up the board for you guys here. There is a few prerequisites you have to set up to make it work. Everything is described in detail in the guide.
And it looks like you're just using a simple micro USB to connect to the board, right? That's all you need?
Yeah, all you need.
Cool.
Micro USB, and there's an onboard debugger and everything, so it handles everything for you.
Nice.
It's a command line tool, so sorry for those of you that are not used to command lines, but that's just the way of things. So what I'm doing here and saying, sorry, Clifford.
Each step is broken down, like explicitly what you would need to write, what you would need to actually type in your survival guide, right?
Yeah, absolutely. You don't have to know anything about command lines to be able to do this. It's explained very, very step by step to get you through it.
Cool.
As I said, it's targeted for an embedded developer and not necessarily a software developer. So what I'm saying here is let's set the board up for our account. We want to use AWS, and we want to use MAR, which is just an authentication method on AWS.
So right now what's
here we go.
happening, it is logging you into your AWS account. It's validating the information that is about to be sent, that sort of stuff?
Yeah, and it's basically taking the certificate that we have stored on the secure element on the board and uploading it to AWS and securely adding the board to AWS. Again, back to security. It's vital.
Cool.
As we're adding that, let's have a look at the AWS console. This is basically where you do all your management in AWS. And this is IoT Core, which is AWS's center for doing these kinds of operations.
Here's where you'll see all your devices, all the interactions that you can have with them, stuff like that?
Exactly.
Cool.
So we can see how I manage things. And there you go.
And it's there.
There it is. And you can start sending and receiving data as you want.
And so what information is it currently receiving?
Currently on board the IoT board, it's a temperature sensor and a light sensor. Since we added the humidity click, if we had actually programmed the board with a driver for that, it also have transmitted the humidity data.
Okay. And where can people go if they actually want to change the firmware of the device, if they actually want to develop with the humidity or whatever other sensor they may be using?
You just go to our GitHub. Easy as that.
Nice.
This is, again, there is a link in the description. This is for MPLAB, I believe. Yes, there is. This is the for AVR version of the board for MPLAB, and for Studio, if you're interested in using the Studio version instead.
And so what you get there is genuinely just all the code necessary to make whatever sort of changes you can make on the board, right?
Yeah, it's the full source code.
Nice. That's
It's everything.
pretty awesome.
So, and it's also built to be changed. We have a bunch of tutorials on that as well. Again, if you go back to the developer guides, for instance, here we have one we call Your First Application, which is runs through how you would actually program the board as well to do these kind of sensor applications.
Cool. I dig it. And so, like we mentioned earlier, all the links to everything that we talked about or anything that we talk about with the questions coming up, we'll make sure to get those to you guys in the description or the comments or wherever else we can. But for now, Johan, was there anything else you wanted to plug before we went over to questions?
No, I think I'm ready for questions.
Let's go. Michael Pierce, what do you have for us today?
Okay, so we do have a few questions coming in.
Nice.
The first one is from Vishnu and a couple of other people. Basically, do we have any Azure support? If I said that right.
You did. You're good.
Yeah. Yeah, so Azure is Microsoft's cloud provider, same as AWS is Amazon's cloud provider. And as it stands right as of now, the question, the answer is yes and no. Yes, in the terms that you can actually connect the board to, like there is support for it in the provisioning tool that we just had a look at, but we don't have any collaterals or tutorials or anything to get you started with it. You're kind of in deep water if you decide to go for Azure, sorry. But we have support for GCP at the Google one and AWS.
Right. And like you said, from a technical perspective, it can and will work if you put the time into it. And
yeah, exactly. But you won't have this curated tutorial like we have for AWS, for instance.
Cool. What else you got, Pierce?
Yep, we have one from Ram, and sorry, I'm not going to try and pronounce the rest of your name because I will mess it up. But which is the secure element that we're using on the board?
It is the ECC306, I believe. Help me out here, guys. I think so.
Is it the 306 or the 608A?
I can't recall.
I think it's the 608A.
I think it's the 608A.
Yeah, okay, there you go. Yeah.
Top of the line cryptographic secure element on a lot of our boards. A great part. Sorry.
Yeah, and there's a lot of, also when you order it, there's a lot of way you can have them what we call pre-provisioned from the factory, and they're quite versatile.
Absolutely.
Okay, and we have one from Shema. I have an AVR board for Google, but I'd like to use AWS. Do I have to get a new board?
Funny thing, the AWS variant of the board and the Google variant of the board is the exact same hardware. So no. You can use the provisioning tool that I just showed you. You just have to put in some other commands to it. And that's also, again, described in the developer guides that we just had a look at.
Cool. So our hardware is kind of like cloud agnostic. It'll work with whatever you put in front of it, basically.
Yep.
Nice.
Yep, and we have one from Alessandro. How is the... I will rephrase this slightly. How
You're
are
good.
the security keys managed on the board? Do I have to install them on the board myself?
So the security keys never leave the private key never leaves the secure element. That'd be a security risk. To not go into too much detail, you don't have to do anything. You just use the provisioning tool, and it'll do that for you. If you're going to go into a more technical aspect of it, basically what it does is to do something called a certificate signing request. It sends that to the board. That's what the provisioning tool does, and it signs it to that board.
You got it.
It's, again, if you want to go down the route that they just show you with the developer guides, there is a couple of tutorials also on how the actual provisioning process works in a bit more detail.
Cool. What else you got, Pierce?
Okay, one from Ninebrain.
Oh.
Yes, that is their handle on YouTube.
I like it.
So, what are the options for IoT boards with ARM and SAM processors?
I believe we have a SAM IoT board. No, we have Clifford.
I believe we do have a SAM. So that's 32-bit support and...
Yeah, that's an ARM processor, just...
Right.
Yeah.
But regardless, I think a lot of the dev boards that we have for 8, 16, 32-bit also are workable with a lot of the shields or add-on parts that allow you to do IoT-based work, whether it be adding a secure element or wireless connectivity. So.
Yeah.
And one more from John. I'd like to write my own code for the board. Is the source code for the board available?
Yes, it is.
Yep.
As we just had a look at, you can go to our GitHub. Links in the description, and you can download it.
Cool. Is that the last one, Mr. Pierce?
That is the last one. If you've got more questions, again, email us at livestream@microchip.com. And I think another one just snuck in.
Oh, okay, cool.
So,
Go for it.
So do we plan to add more examples in Azure IoT in the future?
Well, here's somebody asking difficult questions. Like, there is nothing concretely we have announced as of now. I know that Microsoft has had a bit of a look at it, and it's definitely on our list of something we want to do. But when we eventually get to doing that, I don't know.
Cool. Well, is that the last one? No more squeaker questions?
No, there's another one.
Oh, let's
And
go.
It's actually from my homeland in New Zealand.
Nice.
So from Retinatronics, is this dev board supported by MCC?
Again, yes and no. There is the modules it uses is basically MCC modules. I haven't tested it personally with MCC in the last few months, but I'd recommend probably not to use MCC for the particular IT boards as of now.
Okay.
That might change.
Right, so we're adding support and stuff like that
Yeah.
for the AVRs coming into MCC. I know that the microchip on that board, the 4809, is something that is supported, but like Johan was saying, that is a process that we're going through and making better
let me
and better.
rephrase. If you want to use the already finished firmware that we just showed you, the source code, then I'd rather recommend you, as I said, to not use MCC and just download that directly.
Right.
But if you want to build your own firmware and want to use the Wi-Fi driver, you want to use the MQTT driver, then yes, we absolutely have support for that in MCC.
Yep.
Okay, I think that's about it.
Cool. Well, for the last couple of episodes, I've been ending the question segment with a joke, and today is no exception. And this is one that maybe only Pierce will get. I don't think Johan will. What sort of coffee did they drink on the Titanic, guys? I'll give you a second to think about that. Pierce, do you have any ideas?
Something about sinking.
They drank Senka, which I hope you folks at home are laughing, because our cameramen are.
I think we need to get a new joke book for Kurt.
Yeah, we'll figure something out. Don't worry, we got time. Anyway, so I'd like to give a huge thank you to Johan. Thank you very much for coming on the show. You're an amazing guest. You're a rock star, and thank you for walking us through this AWS journey. If you guys at home have any extra questions, make sure to email them, and we will make sure that Johan answers them as fast as he can. Huge thank you to everybody in front and behind the camera. It takes a whole team to get these going. And biggest of all, thank you to the viewers, because without you, well, my boss would not be okay with me doing this. In 2 weeks, we'll be doing another coffee break where we will be talking about PoE, Power over Ethernet, and all the cool things we can do with that. But stay happy, stay healthy, and I will talk to you in 2 weeks. See you guys.